a lot to cover today. Hopefully I can get this finished. Otherwise, I'll have to change our online test. I don't want to do that at last minute because it's already out there. Excuse me. Anyway, we're really looking at equations of lines and equations of planes in 3D. I've just written a kind of summary of what's going on here. If you want to find the equation of a line in 3D, all you need to do is tell me two things. Tell me the coordinates of a point on the line and tell me what's called a direction vector. That is a vector that tells me the direction of the line. Any vector will do as long as it's that line or parallel to it. Any point on the line will do, which means that the equations are not unique. If you write it like this is essentially the vector form. If you write it like this, it's the parametric form. And if you write it like this, it's the symmetric form. So the equation of a line has three different formats. On the other hand, the other guy that we're going to do today is called a plane. So imagine a plane is essentially just like this. It's like in 3D, it's a flat piece of paper. So every point on this plane, right? So imagine it's beveled at an angle, right? Can I make that look at an angle? There, right? It's beveled at an angle, right? You see it's not horizontal already. And if you want to find the equation of a plane, you only need to know two things as well. You need to know a point on the plane, any one will do. And you need to find a vector, which we'll talk about later when we get to it, called the normal vector. And I've decided to call the normal vector LMN, but you could call it ABC or any other letter. And the equation is this guy down here. But let's focus on the equation of the line, then we'll deal with the equation of a plane in more detail later. So the kinds of questions that you're going to get for the equation of a line, I could just tell you, let's do one as an example. I want the equation of the line that passes through the point 1, 0, 3, and it has a direction vector 2, 1, -1. Right, you want the equation of that. Let's suppose they say they want the equation in its parametric form, then you would just go something like this. 1 plus 2t, 0 plus 1t, and 3 minus 1t. And then you would tidy it up a little bit if you needed to. So that would be the first guy, that would be the second, and that would be the third. And if I write it like this, it's its parametric form. WebAssign, you put a curved bracket around it when you want to do parametric. So if you were writing your answer in WebAssign, you'd have to write it like that. Of course, I could say, I want the equation of this line, the same information, but I want it in symmetric form. So symmetric form, it's x take away 1 divided by that number, y take away 0 divided by that number, and z value, z take away 3, there we go, all over that number. And you would be expected to tidy it up, and it would look, you could tidy it up two different ways, but I'll just leave it like that. Now, symmetric form, parametric form, and finally, vector form. And vector form looks very much like this guy. If you put it all together in one package, which is allowed, you would do that. So, parametric, vector, symmetric. Now, there are little idiosyncrasies that you have to be careful with this guy. Imagine I had a point 1, 3, 4. And the direction vector was 2, 5, 0. Now that would not be a problem with parametric. It wouldn't be a problem with that, right? You would do what you'd expect to do and there's no real hiccup. I mean, 0t just means you don't have any t's, right? But when you do it this way, you have a problem. So let's see what that problem is. X take away 1 over 2. Well, we're all comfortable with that. Y take away 3 over 5. We're all comfortable with that. Z take away 4 over 0. Would you agree that is probably not a good idea? You can't just say Z take away 4 divided by 0. Doesn't work. What you do instead is you do comma, Z equals 4. And the reason for that is that in this line, in 3D space, you're basically getting a line that's floating above the floor at a height of 4, right? It's like a line that goes like this. So the Z value is always 4. So when you do symmetric form, you might have to compensate or accommodate, it's probably a better word, if one or more of these directions are zeros. All that really means is that happens. Now, if you were doing it in parametric form, right? See if it was this guy up here, all you would have is just Z equals 4. And if you're doing the vector form, you just have a 4 at the end, right? So these are pretty easy to accommodate, right? But this one looks a little bit weirder. So far, so good. So if you tell me a point on the line and you tell me a direction vector, I can get the equation in any one of the 3 formats. And it really doesn't matter, depends on what they ask for, what you do. So let's pick a question. Which one should I pick? Let's pick question 6. We're being asked for the equation of a line that passes through the point 14 to negative 16 and the point negative 8, 2, and 13. So you can imagine this is P and this is Q, and we want to find that line. And they want the equation of the line in parametric form and symmetric form, right? So 2 out of the 3. I tend to go for the parametric first anyway, and once I know that one, I can get, you know, the other 2 from that. I need a direction vector, don't we? How do I find the direction vector in this story?
Either take the Q subtracting the P and find the, well, that is a vector of the P, or you can do the opposite.
Yeah, I guess you could. You could find the vector PQ or the vector QP, which agree it doesn't really matter. I would probably suggest you do PQ to keep WebAssign happy. For me, I don't care because it's correct, right? But for WebAssign, I would definitely be thinking more PQ, because since there is theoretically an infinite number of right answers when you do a straight line, it's probably a good idea not to move too far away from, you know, 1, 2, 3, right? Obvious movements. So in this case, 2 take away 1, 2 take away 1, and 2 take away 1. I hope that is correct. Should be. And if you want it in parametric form, then 14 take away 22t. The y, the second one, is 2 plus 0t. And the z, did I just say that? I did, didn't I? Why did I say 2? There we go, 2. And the last one, negative 16 plus 13t. And in WebAssign, you'd have to write down the parametric form like this. And nobody caught my mistake. Come on, guys. What did I do wrong here? Two plus nothing t. I was right the first time. Negative 16 plus 29t. So we have 14 take away 22t, 2, and negative 16 plus 29t. So that's the equation of the line. And in WebAssign, we will write it like that. Now they also want the answer in symmetric form. Okay. So that's going to be x take away 14 over negative 22. I don't see any way of making that pretty, so I'm not going to try. That would be y take away 2 over 0. Agreed? Y take away 2 over 0. But y take away 2 is not our guy. It's just y equals 0, right? Y equals 2. And then the last one is, say again? Are we good?
Your y equals -2.
Technically speaking, it's y minus 2, which I then convert to y equals 2. And then the middle one, well, I guess it's middle here, but it's really from there, is going to be z take away negative 16, which means you add it all over 29. So that guy there is essentially, yep, just checking it out.
So the one with the 0 will always go at the end of the equation?
Yes. Because you want to indicate that these are equal to each other. And if you put the y equals 2 in the middle, that wouldn't be possible. So if the x is a 0, you'd have a y and a z, equal, and you stick the x is 4 at the beginning. How are we good with that?
Why is the 22 negative?
Why is the 22 negative? Negative 8 take away 14
Oh, got it.
gives
I
you
did it
negative
backwards,
22.
never mind.
I always say second take away the first. That's how I remember it, right? Second take away the first.
Okay.
Q
that
take
makes-
away P. Right. Are we good with that one? Okay. The next one, well, the next couple of questions are going to be equations of lines, but I'm not necessarily going to take them the whole way. If I can find a point on the line and I can find the direction vector, can't you finish it off in the usual way? So I'm now only going to focus on doing that part of the puzzle. So in question 7, you're being asked for the equation of a line that passes through the point negative 8, 6, 7. And then they say parallel to the line 1/2 x equals 1/3 y equals z plus 1. That is the equation of a line. As weird as it looks, that is the equation of a line written in symmetric form. Now, the way they've written it is making it harder to realize that that's what it is. So I'm now going to write it like this. Mathematically, isn't this exactly the same as the one above it? But when I've written it this way, you should be able to tell what the direction vector of this vector is. What is the direction vector of this guy here?
Is it 2, 3, 1?
Correct. The numbers that are on the bottom would be the direction vector. A, B, C. Agreed? Now, do you see how they kind of muddied the water here by the way they've written it? So sometimes you have to think of a better way to write it. Now, I have everything that I need. I have a point on the line, and don't I have a direction vector? Because my vector, right, my straight line, is parallel to this guy. So if he's parallel to this, doesn't he have the same direction vector as him? That was the answer. If that's the line and this is my line, I'm parallel to you, but isn't my direction the same? And not that it matters. They want the answer to that question to be in parametric form and symmetric form. So moving on to the next one. Too easy. But I'll tell you what it is anyway. It's passing through this point and a direction vector parallel to the vector -1, 4, -4. Well, if you're parallel to them, shouldn't you just use that as your direction vector as well? So there's the point you're going to use. There's your direction vector. Put them together and parametric, and I think they also want symmetric form. And that was about it. Oh, I should actually show you something. Yeah. Imagine that you have a line in 3D space and it's going to hit the floor, right? This is called the XY plane, right? Floor. Would you agree that the geometry of it says that if you have the floor and you have a line coming in, got that? Want to intersect the plane in only one place. So imagine I have a line written down in its parametric form, and my line happens to be 3 plus 2t, 4t, and -1 minus t, right? Just for argument's sake. And I want to know, where does this line intersect the XY plane? Okay, so essentially the floor. Now, since I know that the straight line is only going to meet it once, the way that I'm going to solve this problem is by taking this information and doing something else. I'm going to write the XY plane as the same thing as the Z values are all 0. Does that make sense, that on the floor, the XY plane, the Z is 0? And then I say, okay, well, this guy is the Z coordinate, and this is only going to equal 0, right? So I'm matching them up. Essentially what I'm looking for is the T value that works, right? So I'm saying the Z has to be 0, right? So this has to be 0. If I add T to both sides, I now get a T value of -1. I can then go here and put T equals -1 into my parametric, and I get X is 3 plus 2 lots of -1, Y is 4 times -1. And if I wanted to, but I already know it, isn't Z going to be 0? And what does that guy get me? 1. What does that guy get me? -4. And that guy gets me 0. So the point of intersection will have coordinates 1, -4, 0. So if you want to find out when a line crosses the XY plane, take the parametric equation and make Z 0. Find out the value of T that makes that work and plug that same value of T into here and here, and that will be your coordinate of where it crosses the XY plane. Suppose I wanted to know where it crossed the XZ plane, because that would happen as well. Can you imagine a vertical wall? The straight line would hit it somewhere. If the XY plane is the same thing as the Z coordinate is 0, what is the XZ plane the same thing as?
Y equals 0.
And so if I was doing this question, right, this straight line, if Y was going to be 0, wouldn't this cover them up? Wouldn't all I need to do is find out what value of T makes that guy in the middle 0? And would you agree that's T equals 0 this time? What makes 4, 2, 0? T equals 0. And if I used that, I would get the answer 3, nothing, -1. because if you make that 0, you get 3. If you make that 0, you get -1. And for completeness sake then, and what's the one I haven't done? If I wanted to find out where my line intersects the YZ plane, then wouldn't I make x equals 0? You noticed the connection here? XY plane means Z is 0. XZ plane is Y equals 0. And the XY plane is X equals 0. And if I go up here and I try and solve, 0 is 3 plus 2t. That makes t that fella. And then I would plug that in here and get 0, of course. I'd plug it in here and I'd get -6. And I'd plug it in here and I'd get a half. And so that's where it crosses the XZ plane. This is where it crosses the YZ plane. And this is where it crosses the XY plane. So have we got the strategy for where a line crosses any one of those 3 planes? Doesn't really matter which one you. I think the question I'm looking at is question
Question.
8. Yes.
What if one of the plane moved down like at least 1 unit? Then do we just put the that unit into the plane that is y is equal to 0? Like if, example, if I have XZ plane move down 5 units, should I make my y is equal to 5?
No, but I understand what you're getting at. That would make perfect sense. But what you do if it's not these planes, these are special planes. These are like the analogy, the x-axis and the y-axis, right? They're very special axes. These 3 planes are very special. One's the floor, one's this side, and one's that side. If you wanted to do a plane that was above it, or even more difficult than that, can you imagine that the plane was angled? And your straight line is coming in like this, then there is a way to solve that, but it's not this way, right? And we'll show you. I actually look at my pretend watch that should be here. We will get to that, fingers crossed. So that was a version of question 8 we just did. So we know how to get the equation of a line, or at least a couple of ways to do that, depending on the information. The next group of questions, that's definitely question 9. Question 10 does the same. Keep going, question 11 does the same. That's it. Right, the last bunch of questions are all to do with, I'll give you they will give you the equation of 2 lines. And you are trying to decide which one of the following 3 things is true. Are the 2 lines parallel to each other? So would they look like this in 3D space? Are the lines skew? Skew is the name we give to it when the lines look like this. It's hard to do this in 3D, but can you imagine that the 2 lines never meet? They like fly over each other, right? Like this, see that? They'll never meet. We call that skew. Now, if you look at it above, doesn't it look like they make an X and they intersect? But if you look at it at a different angle, you see they never meet. When 2 lines never meet like that, they're called skew. And the third situation is intersection, right? So they intersect. And when you do 2 lines and they do intersect, although my picture might look the same, that would be like this, right? They are physically crossed. So you're going to be given the equation of 2 lines, and you're going to have to figure out which one of these 3 is going on. It's a very short question with a lot of work. Right, here's 2 lines. Let's pick one. Question 11. The 2 lines happen to be written down in their symmetric form, but it really doesn't matter how you write them. So the first line looks like this. Oops. That's Z take away 12. I don't want to have to rewrite that again. So that's one very big long negative. Right. So first thing you check for. Check if they're parallel. Should be 1R in parallel that way. Now, if you look at line L1, if I asked you what its direction vector is, I'll call it V1, it's a vector 1, -2, -3. If you look at line L2 and I asked you what its direction vector is, you would say it was 1, 3, -7. Can someone tell me an easy check to tell if two vectors are parallel or not?
They're not parallel.
Correct. How could you
Yes,
convince
because,
someone who doesn't know?
well, even though the x-axis or the x direction is heading the same way, but well, the y and the z is not the same.
Okay. So how about this situation then? 1, -2, -3, 2, -4, -6. Are they parallel? Because they don't have the same numbers. But are they parallel? Any takers? Is that parallel?
Yes, they're a
Correct.
factor different.
If you divide them, the factor is a half each time. In other words, one of them's half the other. That's what parallel looks like. So it's not so much the fact that the first one's the same and the others are different, although in this case that means what you said and you were bang on your logic. But in general, they may well be different numbers, but that doesn't guarantee that they're not parallel. So the better check is 1 divided by 1 is not the same as -2/3, and that's not the same as -3/7. Do you see that quick division? X with X, Y with Y, Z with Z. If you get the same ratio, the same factor, what other word? The same fraction, parallel. If they're not, they're not. All that has done is said it's not parallel. But it could be skew, right? They could fly above each other, or they could intersect. So what I'm now going to do is I'm going to try and find out where they intersect. And if I can find an answer to where they intersect, then it means they intersect. And if I can't get a solution to that, it means that they don't intersect, in which case we'll call it skew. Right, so that's going to be the logic, right? The format that these are written in doesn't really lend itself to the algebra I'm about to do, so I'm going to rewrite those two lines in their parametric form. So this is going to be x equals, what's that going to be? Well, if you make that equal to t, you get 3 plus t. This guy, you get 1 minus 2t. And this third one, you get 12 plus 12 minus 3t. Now, if you're wondering where I'm getting this all from, I'm just making it equal to t and solving, right? So cross multiply, add 3. Cross multiply, add 1. Cross multiply, add 12. So that's what L1 looks like. I think I should put L2 next to it then. In parametric form, make this guy equal t, cross multiply it, and you will get 4 plus t. There's a quick way. Make that negative and you use the same number. Make that negative of itself and use the same number. And I just made a boo-boo, so I will rewrite it. I'll rewrite it down here. And x is not going to be 4 plus t, it's going to be 4 plus s. and y is going to be -6. Add 3s, and lastly, z is going to be 13, take away 7s. Now you might say, what's the big deal? It's the same numbers. Can't you just use the numbers, you know, that you want and the letters that you want? No, because we want these two to be distinct. And if I make this t and I use that t, what I'm saying is that those two lines are traveling in the same timeline, right? There's no reason why they should. Couldn't one of them be going quite fast along the line and the other's going quite slow, right? So we need to distinguish. So each line should have its own dummy variable. Now, I said I'm going to try and find out how these two lines are, where they intersect, if they do. So I'm going to call this guy 1, 2, and 3. And I'm going to call this guy 1, 2, and 3. And I'm going to say that if they do intersect, the two ones be equal, right? So that means that 3 plus t should equal 4 plus s. Right, so the x coordinates will be the same, and y take away 2t should be the same as -6 plus 3s. So I'm going to solve this system of equations. When I'm finished, t is going to be 5 and s is going to be 4, or whatever it is, right? That's going to be done, right? You can pretty much guarantee that's going to happen. When that does happen, how do I tell if I've got an intersection or not? Well, you take the t that you got and you plug it in here and you see what the z coordinate is, and you get the s that you got as your solution and you plug the s into here and you get what the z coordinate is going to be. And if these two are the same, you've got an intersection. And if these two are different, you've got a skewed. So that's going to be the logic. So now we're bringing a bit of math that, oh God, it's well, it's a 94. That's what I think, that's where it, yeah, it lives in math 94. I'm going to call this equation A and equation B, but I don't like the way they're written. So I'm going to subtract an s from both sides and subtract a 3 from both sides. So that's my new equation 1. And I'm going to subtract 3s from both sides. And then I'm going to subtract a 1. Not the prettiest answer in the world. There's my two equations. That's a nicer way to write them, isn't it? When you think back, think of 4x plus 2y. You can solve these equations by using a method called the addition method. You can solve these equations by using a technique called the elimination substitution method. So you see, our dog's sitting down here. She's had an operation, so we're all kind of watching her. So anybody, both methods work, but I tend to go for the one that I think is the least amount of work. Any suggestions about how to tackle solving this equation? She was drinking a little bit and she was eating, so that's good. And she also didn't like the guys battering the roof at all. Yes, I understand. Right, suggestions. What you got here? Come on. Addition
Elimination.
method. Elimination. I like elimination. I'm going to take equation A, and after doing all the work I did, I'm actually going to add s to both sides. Because in the elimination method, what you do is you make one of the variables, in this case t, equal to 1 plus s. And then you put the t, which is 1 minus s, into the other equation. The other equation is -2t, -3s equals -7. So it's -2t, take away 3 lots. Oh, I've put it in the wrong place. -2, 1 minus s, there we go. Take away 3s equals -7. So I'm replacing this t with 1 minus s, you see it? So -2 plus 2s, take away 3s is equal to -7.
Should it be t equal to 1 plus x, s, or t equal to 1 minus s? Because
Oh, thanks for catching that. There we go. Yeah. So -2, take away 5s is -7. -5s, adding 2 to both sides, and s is equal to 1. Now, if s is equal to 1, can't I then use this relationship and find out who the t should be? And the t ends up being 2. So I said, look, we're going to solve this system of equations any way you like. I mean, there's lots of other ways. Couldn't you put it into Desmos and find out where the 2 lines cross? Whatever works, right? Now, in this case here, what we're going to do now is figure out what happened in the Z. Well, in line L1, the Z coordinate is 12 take away 3t. In line 2, the Z coordinate has the formula 13 take away 7s. So let's see what we get. 12 take away 3 times 2, the Z coordinate here is 6. Z equals 13 take away 7 times 1, the Z coordinate is 6. Do you see a match? The same Z coordinate. What that tells us is that we have a intersection. If this was 6 and that was 22, which could happen, we would have skew. If these are 4 and this is 4, we have an intersection, right? That's basically it. Now, if you wanted to find out what are the coordinates of the point of intersection, couldn't I just take s equals 1 and put it in here, here, and here, and that would get me the xy coordinate? Or if I wanted to, couldn't I put t equals 2 into here, here, and here, and I would get the same result? And the point of intersection, let's risk it. I'm going to use this one. 4 add 1 gets you 5. -6 add 3 gets you -3. And 13 take away 7 gets you 6. Now, if I was a bit skeptical, I would try t equals 2 then. 3 plus 2, yep, 5. 1 take away 2 times 2, yep, -3. 12 take away 3 times 2, 6. Would you agree? It didn't matter which one, I got a match. Plus, it's an extremely long question, right? So don't you want them to be parallel? Because that would have finished 10 minutes ago. But if they're not parallel, haven't you got a lot of work to do? Now, it could happen that you may get lucky. Let's suppose that they're not parallel and you did this equation here, right? And you tried to match them and you did the math. And if you think back, can you remember sometimes you try and solve a system of equations and the answer is impossible, right? All the t's disappear and there's nothing left. Won't that tell you it's skewed? The reason you can't find a solution is because there isn't one, right? They're skewed, they're flying above each other. So if you get a skewed, you might get lucky and it fails here. If not, you might get a solution, but when you check the Z's, it fails there, right? This is 6, but that's 10. And I am not doing another one of those guys for lots of reasons, but 10 and 11 are for you. Any questions before we move on to the equation of a plane? Okay. Now a plane is in 3D. I'm going to try, it's hard to draw it, but I'll do my best. A plane in 3D. Can you imagine a sloping flat piece of paper forever? We call these things a plane. And the equation of a plane, you only need to know 2 things. you need to know any point on the plane. So can you pretend I know the coordinates of this point and it happens to be 1, 2, 4. And then you need a guy that's called the normal. And you might think, what on earth is the normal? Is it like a direction vector, like a vector in the plane? No, it's actually kind of the total opposite of that. The normal is a vector that is orthogonal to the plane. So let me try and visualize one for you. Here we go. Here is my sloping plane. There's my point. This pen is orthogonal to that plane. If I turn it side, well, I know. If I turn it that way, can you see it's at right angles? So if you were living on this plane, Jeremy, and you were looking upwards, wouldn't the normal be the direction through your legs and your head, right? It would be going that way. And once you know that, the formula for getting the equation of the plane is these three numbers with x, y, and z, and these three numbers with the coordinates x1, y1, z1. Cool. Now, I'm actually going to, not that you need to, but I try when I have time at least, to prove things to you. So let me try and prove this one to you. Imagine I have another point called Q, and its coordinates are x, y, z, because Q is any point on that plane. Great. That's what I'm saying. Now, N has values L, M, and N. Got that? And technically speaking, this guy now is going to be x1, y1, z1, right? It's any point. In this case, it was 1, 2, 4. Now, if you do the vector PQ and you do a dot product with N, won't you get 0? Because if you take any point on the plane, won't PQ be orthogonal to the N? Does that make sense? If you draw any line on the plane, isn't it going to be at right angles to that normal guy, no matter where you put it? Now, PQ is going to be x take away x1, y take away y1, z take away z1, and the normal vector is L, M, N, and that dot product is 0 because they're orthogonal. And if you do the dot product, you get this. Oops, that's an X. You get this guy. You get this guy. And you get this guy equal to 0. And then if you multiply, distribute them out, you get that. And if you leave these three guys on this side, but add that one, and add that one, there's that equation. Okay, so it's not magic. That equation does come from, a good reason. So I say you don't need to be able to prove that. I just thought I'd show you that because I could. So let's go hunting for equations of planes. Right, the simplest one would be question 13. I want to find the equation of a plane that passes through the point 6, -3, 6, and it has a normal vector of -1, 4, 5. Now, they actually didn't call it the normal vector. They said it was perpendicular to that guy. But if you're perpendicular to that guy, you are the norm. So we got the guy. So I'm going to call this one x1, y1, z1, and L, M, and N. So what do we get? We get -1x plus 4y plus 5z. And it's going to equal essentially the dot product. So -1 times 6 plus -3 times 4 plus 6 times 5. And so the equation is, what's that? -6, -12 plus 30. I believe that comes to 12. So if you want the equation of a plane that passes through this point and has a normal vector of that type, you're done. Let's talk about uniqueness. Do you think that's the only equation for this particular plane? What do you think? Could I have another plane that would also represent this guy? Another equation, I should say. The answer is, I'm getting old here, guys.
Yes.
Older. Yes, good. You know, I wouldn't be asking the question so long if the answer was no. I'd just say, hey, you've got the only answer in the universe, don't worry about it. But we know from straight lines, isn't there an infinite number of answers? Which does beg the problem. Aren't you going to have some issues with WebAssign if you don't pick the one it wants? So, you know, keep things simple. So you might say, well, what other equation could I get? Well, I could get -2x add 8y plus 10z equals 24. You know, that one would work. Didn't I basically just double everybody? So although the answers to the equation of a plane are infinite, right? There's an infinite number of ones. There is one thing that kind of puts them together that you don't really get with the straight lines. Won't all of them be multiples of each other? I don't know if that's an interesting fact or not, but it is. Suppose then we did a question 14, where we're told the coordinates of the point is 7, -2, -4, and we're told that it's parallel, there I go with 2 R's again, parallel to the plane, z equals 3x take away 4y. Now they're doing 2 things here to make your life hard. First thing is they haven't told you the normal. Second thing is they haven't at least given you the equation of the plane that's going to help you get the normal. What do I mean by that? If I tell you a plane has the equation, that guy, if you pull out these 3 numbers, isn't that the normal that was being used? Agreed? So many x's, so many y's, so many z's. The coefficient of x, y, and z is the normal for that particular plane. That was the one that was being used. Of course, in the one they gave us, they didn't write it the way it needs to be written. Oh, and by the way, I don't care if that's 10, 100, or 1,000,000. Isn't it still the same normal? That number there has no effect on the answer. Right? So back to this one, it's not written the way it needs to be written. If I subtract z from both sides, wouldn't it look like that? Agreed? Subtract z from both sides. What is the normal of this plane then?
3, -4, -1.
Don't I have the LMN that I need? Because if you are parallel to a plane, the logic is, shouldn't you have the same normal as the plane, right? If 2 planes are parallel to each other, wouldn't their normals be parallel, right?
Question. So
Yes.
if we take the dot product of those 2, then it would become 0, right? Since I know that from the equations are given, it is equal to 0.
The dot product of this guy with who?
With the point, the x1 plus my1 plus nz1.
No, you won't actually get 0. You'll get a number, and it's whatever this number here is, typically. The guy that's going to be 0 would be p to a general point. I use that only to prove the equation. But in the way the equation's written, this combination of x, y, z will equal whatever this number is. This number won't be 0. If it was, we wouldn't need this. Wouldn't we just say equals 0 every time? We know that that isn't the case. So to finish this guy off then, what I would be doing is I'd be saying 3x take away 4y minus 1z. And I wouldn't say it was equal to 0. I'd say it's equal to the dot product. So I'd say it's whatever 3 times 7 plus negative 4 times negative 2 plus negative 1 times negative 4. And that's what it would be equal to. And in this case, 21, add 8, add 4, 33. So the equation of the plane that they are looking for is 3x, take away 4y, take away z equals 33. So try not think that that's going to be 0. Now, if you want to do a dot product with this guy, what you're going to have to do is find 2 points on the plane, right? Find another guy that you know on the plane, right? So you get P and you get Q. And if you found the vector joining them and dot product with this guy, that would be 0, right? But I don't think they do a question like that. This is just a single point on the plane, so it's not even a vector. Are we good? We are hitting, yeah, I knew it had to come sometime. We are hitting a place where you have got a lot of work to do. The question I'm talking about right now is question 15. Actually, 15, 16 do the same job. Suppose I give you the coordinates of 3 points, P, Q, and R. Now, if you imagine them being written, they might look something like this. Unless you're very unlucky and they're collinear, which means they're all in the same straight line, won't you make a triangle? And if you have a triangle, shouldn't you be able to have an equation of a unique plane that passes through the triangle? So this question becomes, find the equation of a plane that passes through 3 points, P, Q, and R. Right, so that's the question. Find the equation of a plane that passes through those 3 points. So we need a strategy. There are only 2 things I need. Would you agree? I need to know a point on the plane, and I need to know this funny guy called the norm. I can tell you the point on the plane without trying, and I'm going to pick P. Right? I like P, so I'm picking P. Now we need to figure out how to get the norm. Because once I've got that guy, we're a plug and chug, right? We've got a formula. Oops. Plug and chug, right? How am I going to get the normal?
Couldn't you just find the vector between any of those 2 points and then find a line perpendicular to that?
I like your thinking. So I'm going to pick PQ, and I'm going to pick PR because I like P. What how do you find a vector perpendicular to two vectors? We have a guy that does that, don't we? What's it called?
The dot product,
Go the other way. What's it called?
cross product.
Yes. So that's how we're going to get the normal. We're going to find a vector PQ, we're going to find a vector PR, and can you imagine that when you get the guy that's at right angles to them, right, won't that be the normal? And once we've got those two guys, the question's over. So here's PQ, I should say, here's PR. So second, take away the first, 4. -1, take away 2, -3. 0, take away 3, -3. That's fine. PR now. Second, take away the first. Second, take away the first. Second, take away the first. Are you happy about PQ and PR, where those numbers came from? And we're going to get the cross product. So we have an I, we have a J, and we have a K. And that guy goes there. And this guy goes here. And it's so many I's, take away so many J's, plus so many K's. Okay, you cover that fella up. What do you get? You get 12, take away -9. If you do the middle one, you get -16, take away -3. If you do the last one, you get 12, take away -3. So that guy add 9 gets me 21. That guy is -16, add 3, which is -13, but then you take the negative of that and you get 13. And 12 add 3, you get 15. We have found the normal. That's all I need. A point on the line and the normal vector. Right. You put those guys together, your equation will look like this. 21x plus 13y plus 15z equals, and since I don't have a lot of room and I want to get this done kind of quickly, I'm going to do that calculation here, already done. So it's going to be 21 times 1, add 13 times 2, add 15 times 3. And the answer is 92. And we're finished. The equation of a plane passing through any 3 points is going to be done by pick the first point, in this case, this guy, right, as your point. From that point, do 2 vectors, PQ and PR. Cross product of them gives you the normal. Once you have a point and the normal, plug and chug formula. Now, I picked P because I like P. Suppose I picked R. Wouldn't I do RQ and RP? And that would be fine, and I'd get an answer. Would it be the same as this? No, but it would be a multiple of it, right? It might have been -2 times it, it might have been -1/2 times it, it might have been 1/2 of it, or 17 times it, or whatever it would be, right? But it would be in the family of it, right? Even although they're all slightly different looking, which is better than straight lines, because straight lines can look totally different from each other and still be the same straight line. How are you with that process? Do we feel good? Right. I mean, it's more time consuming because there are a lot of numbers, but it is good.
Oh yeah, I forgot. Where did the 92 come from again?
I got it by doing 21 times 1, the dot product of 21 times 1, 13 times 2, and 15 times 3, and adding them all together. Essentially, I did that calculation here in one go on my calculator, rather than writing it all down.
Oh, okay. Thank you.
Now, there are lots of different things you could be getting for the equation of a plane, but it was pretty good. Now, let's return to a question that we did earlier. Remember a straight line hitting the XY plane? Remember that guy? Let's have a straight line just hitting any old plane, right? So I have the straight line whose parametric equation is 2 take away 2t, y equals 3t, and z equals 1 plus t. And whenever you're going to do a question where a line is intersecting any kind of plane, the parametric version is really the go-to way of writing the equation of the line, right? So there's my line. And right next to it, this is the equation of the plane. Now this one doesn't require, thankfully, a lot of work. Any suggestions about what I should do next? I need to know where this line meets up with this plane. So can you imagine there's my plane? Here's my line. I want to find the coordinates. Any takers? I mean, I'll take a wild shot in the dark. Any ideas? Look at where I'm pointing. X, Y, Z, X, Y.
I have a suggestion. So
Go for it.
can I just substitute all the x in it with all the thing that it has, like 2 minus 2t plus 2 times 3t minus 1 minus t equal to 4?
Nailed it. That's how you do it. Does that make sense? That basically you just substitute the x, y, and z values of the line in terms of t into the x, y, and z value of the plane. Now, when we tidy this up, aren't we just going to have an equation with a t, right? So we can solve it. So let's see what we get. I get 2 take away 2t plus 6t minus a 1 minus a t equals 4. And that guy, what does that get me? That gets me 3t. And that guy gets me plus 1 equals 4. And so subtracting 1 from both sides. And now I have solved for the missing value of t. Well, we're 90% of the way finished. But I don't know the coordinates of the point, but I should be able to find it. How can I use that to find the coordinates of this point here?
Can you just plug it all back into the original line?
You nailed it. So 2 take away 2 times t, y is 3 times t, and z is 1 plus t. And so what's that? 2 take away 2 is 0, 3 times 1 is 3, and 1 times 1 is 2. So the point of intersection is that. Does the logic of how we found this make sense to you? Does it, right? Equation of a line meeting up with a plane. Replace the x, y, and z's with these guys. Solve for t. Once you know t is, plug it in here, and that must be the x, y, and z. Now I can check it. Since I've got time, I can do that. X add 2y take away z should equal 4 if you're on the plane. So 0 plus 2 lots of 3 take away 2 should equal 4. and 6 take away 2 should equal 4, and 4 does equal 4. Isn't that a check that it actually works? Right? That this point actually is in the plane, and we know it's on the line because we just plugged 1 in and got the point. So far, so good. Now, let's imagine complications. Suppose I have an equation of a line and an equation of the plane, and I do the substitution like we did here, and this happened. All the t's disappeared, and there was a 10 on the left and equals a 4 on the right.
The line doesn't meet the plane.
And so you would, if you want to visualize what that looks like, wouldn't that be parallel to the plane? Like, an aircraft flying above the surface, right? Never meeting it, always keeping the same height. Now, this is trickier. You plug it in, you do all the stuff, and the t's disappear on you. But that's what's left. And that's not the same as this situation. What does that tell you? So here's my plane. Where's my line? I mean, it exists.
The line's on the plane. It
Yeah.
is one with the plane.
It is one with the plane. I like that. Yes, it is one with the plane. If you want a jargon for it, it's embedded in the plane. So this technique, won't it tell you intersection if there is one? Oh, and by the way, if there's an intersection, isn't there only one? Right, a line can't curve back on itself and hit the plane a second time, right? That ain't going to happen. So if there is an intersection, there's only one. If this happens in your math, parallel, right? The line doesn't meet the plane, it's parallel, it's flying over it. And if this happens, the line is actually embedded in the plane, right? It's one with the plane. So how about this puzzle? Question 20. Where does the line that passes through -3, 1, 0 and the point -1, 7, 8 intersect the plane with the equation 2x plus y take away z equals -2. Now, it's very like question 18, but it's going to involve a little bit more work, isn't it? Because,
would you do the second subtraction 1 to get the vector and then put it in the equation form of like that, and then substitute back to the x, y, and z, right?
yeah. So we're going to do a little bit of A and a little bit of B. So the first thing I'm going to do is find what the equation of the line is, which we kind of did at the start of today, right? So I want to find the equation of the line, just like you said, joining P to Q, right? So the direction vector is going to be second, take away the first. So -1, take away that guy is -1, add 3, so that's going to be 2. 7 take away 1 is 6. 8 take away that guy is 8. And I'm going to choose P, the first one, as the point for generating the equation of my line. And then in parametric form, I can now write down what the equation of that line will be. It will be the point -3 plus 2t's, 1 plus 6t, and 0 plus 8t. And I'll just write 8t because I don't want to have to rewrite it again. So here is the equation of our line. So we're kind of here now, aren't we? And just like we did here, aren't we going to plug these 3 guys into the equation of the plane and solve? So 2x plus y, take away z is -2. Have you noticed why it's a good idea for me to put a stroke through my z's?
Because the
My
Z look
Zs-
like the 2.
Oh God, my z's look really, really like a 2. And don't my s's look like a 5? Have you noticed when I do my s's, I do that to them to stop them looking like a 5? Right. So, will you try and do the same thing if you have, you know, if your 1 looks like a 7, will you do that? So nobody, you know, because I've seen people who do ones that look like that, and their 7s kind of look like that, but sometimes their 7 is kind of, I'm not sure, right? It's halfway between what a 1 looks like, and it's halfway, not a good thing, right? So drifting, here we go. 2 lots of this guy, add this guy, take away this guy. It should equal -2. So -6 plus 4t plus 1 plus 6t, take away 8t is -2. And this guy and this guy and this guy get me 2t. And this guy and this guy get me, what's that? -5. And if I add 5 to both sides, I get 3. And so I have 3 halves. How does 3 halves look? Looks good. Right. I'm just expecting t equals 2 or 4 or something, right? But 3 halves is not that bad. So almost done. The x coordinate is -3 plus 2 lots of t, which gets me, 0. And the y coordinate is 1 plus 6 lots of t, which I believe gets me 10. And the z coordinate is 8 lots of t, which I believe gets you 12. So the answer to this question is point of intersection is 0, 10, 12. And it's unique, right? If there's 1, that's it. There isn't any others. Okay, we've got a few minutes. I want it to be useful. Is there anything that we've done from questions 1 to questions 20 that you'd like to see another example of? And I've probably got enough time to squeeze in one more shot. Is there any in the homework that look maybe not quite the same as the ones I've done, so you might want to see an example of how to do it?
Could you do example 3?
Sure. So, question 3. See what it's about. So question C says, find the vector equation of what? Actually find the vector equation, and they also want the parametric, so I guess they're looking for 2 answers. Of course, it's going to be a line, and it's a line through the point, so I'm going to call it P, 8, 0, -3. That's good news, right? I got a point. And now the sneaky one. It's parallel to x equals 4 take away 4t, y equals -1 plus 2t, and z equals 6 add 8t. Now, this line is parallel to mine. So if you imagine this is their line, my line is parallel to it. So won't my line have the same direction vector as this line? So I should be able to, just by looking at this equation, I should be able to pull out what the direction vector is. Right? It's a combination of these numbers. For instance, what one of those two is the x component of the direction vector?
-4.
Which one? Right, it's the coefficient of t. And in the second one, 2. Great. And in this last one, it's 8. Are you comfortable about how we suck those three numbers out to get the direction vector?
Yeah.
Right, so once you've got a point and you've got a direction vector, you're pretty much home and dry. So let's do the parametric first, because I like parametric. And it's going to be 8, take away 4t. It's going to be 0, add 2t. And it's going to be -3, add 8t. And in WebAssign, you're going to have to write it with the funny little curved brackets. Although I think WebAssign already gives you the brackets, so you just need to stick these guys in. Right, so you're going to put a little comma between them all, and that's how WebAssign wants you to do the parametric, right, this way. Now, you also have the vector equation. That's the notation that we use. And the vector equation, for all intents and purposes, looks identical. You agree it's just the same guys. The only major difference is those little guys. That means you can do it with these funny brackets. And I'm pretty sure that WebAssign will also allow you to do that notation as well. Which brings me to your online test. You can't write I, you have to write that version of I. Which, if you're going to do it, remember it's inside the vector submenu. So when you click on it, go look for vectors. There's a guy that might not look like that. It looks like the bold version of that, but that's the guy you can use. You can't just hit the keyboards, because I went through your test and I saw people essentially writing the right answer, but using keyboard IJK and not vector IJK, right? So just be careful about that. Anything else I noticed about that? No, anyway, your test is now online. That's this one. And I know it's very late, but this week has been really hectic for me. Solutions to the last one are now there. So at least the answers to the last one, you can go in and look for your own answers, but your grade is there. I guess that's what I'm trying to say. That one went pretty quickly. Is there anything else? Or are we going to call it a day? Okay. Last name, bye-bye. I'll hang about for any homework questions.